Docker. It is a tool that lets you run your application in an isolated environment. That isolated environments are called containers. Since containers are isolated and contains all of the information and dependencies about an application inside them, you can easily run multiple applications and multiple versions of your application on a single host. Containers are started using an image. Image is the blueprint of how the container should start and what it should contain. And regarding what it should contain, it will obviously contain the application that you want to run inside a container. The host running in containers can be your laptop, can be a desktop server, even it can be a Raspberry Pi. So in this video, we are not going to see how to use Docker containers. We are going to dive deeper inside and learn how the container actually works. If you want to learn how to use it, then go and read the documentation. Anyways, we are going to interact with the container from inside it and try to learn how it isolates application and play with some Docker features that you would love to see. Stay tuned and roll the intro. I am Anis, you are watching BlockX3. Let's get started. Docker is only meant to run on Linux. Other OS like Windows or Mac OS uses a virtual machine, and inside the virtual machine a Linux is running, and that Linux is running containers. Why only Linux though? Because Linux has two features called as cgroups and namespaces, which allow them to isolate processes running on a Linux system. Let's start with very basics. Any program in execution is a process for operating system. For example, if you are watching this video in browser or in YouTube, both of them are running a process inside the operating system. Since all processes that are running in an OS are using same OS and memory spaces, they can see each other and communicate with each other easily if they need to. For a security point of view, what if you want to isolate a process that cannot talk to and cannot even see other processes in the host machine? That is where namespaces come into play. Linux kernel has a feature called namespaces that can isolate process in a separate namespace that cannot see any other process outside of its namespace. There are 5 types of namespaces that are acting to isolate a running process. They are process ID namespace, network namespace, inter-process communication namespace, UTS namespace, and mount namespaces. When we are isolating a process, maybe we also want to limit the resources a particular process can use. For example, we can limit CPU, RAM, storage, network I/O used by the process using something called as cgroups or control groups. It is also a feature of Linux kernel which allows us to limit the resources used by a particular process. Cgroups allows the Linux kernel to make a group of processes and allocate resources based on the group. I can limit how much RAM these groups can use, how much CPU they can consume. Using cgroup, Docker allows us to limit resources in a very precise manner. Precise enough to limit the container to only let it use a particular core of host CPU. Let's see in action. These are the flags that we can use while starting a container in order to limit the CPU that a particular container can use. We are going to use one of this flag which allows us to limit the particular CPU core that a container can use. We can do this by using this flag. So I'm currently in a VM that I use for testing purposes. So if I start a Ubuntu container in this VM, now that I have used this flag to start the container, I will be directly getting inside the container. And now while staying in the container, if I do a stress testing using a tool called stress, so now that we have installed the stress tool, we can use it to stress test how much this container can use at max. Simultaneously, we are going to open htop in the virtual machine so that we can see the container uses. And if I start this now, -c flag 1, it will start to stress out, but it will only stress out to a max of this core number 0. It will not exceed that. Why? Because we have set the core number 0 while starting the container to be used for this container. So it will not go beyond this particular core. Although if we use any number of CPU used by this stress command, it will not affect how much resources it can use. It will maximum go up to the 100% of this particular core. Namespaces and C groups are only isolating and limiting the resources a process can use, but the process is actually still running on the same host. So this is what makes it different from virtual machines. The process are running on the same kernel as the host, but the difference is they are running in different namespaces and C group, which makes them isolated from the rest of the process. For example, I have a running container of portainer. If I search for the process name in my host machine, I can see the same process running here. The ID is 20AD91D, 20AD91D. The same portainer process which is running as a container is the same process that is running on the host machine. So the conclusion is, this is your Linux machine. It has its hardware at the base level. Again, over this hardware, the actual Linux kernel is running. Over this Linux kernel, all of the application processes are running. So all of these application processes are running in namespaces, as we already have talked. So all of the processes that Linux kernel run are in same namespace. Let's say it be a host namespace. And let's say this is the process that is running on the Linux kernel in the host namespace. Let this be one process, let this be another process. For example, it can be your Google Chrome, this can be your file manager. These are the processes that runs under host namespace. Now when you create a container, Docker creates a separate namespace. Let's say we saw an example of portainer. So let's say the container portainer is running in the namespace of, let's say, portainer. So this particular process of portainer is running on the portainer namespace, but it is actually running on the same Linux kernel and same host machine, but it is only partitioned by namespaces so that no other processes can see it. Now let's break down what happens when you enter docker run particular any container in your CLI. So when you run this command in CLI, docker run, for example, nginx container, so your CLI is a client which is making an API request to Docker engine, and Docker engine is running as a process, as a daemon in your Linux system. So when this API call is made, the container creation process starts by Docker engine. So Docker engine utilizes two more components in its ecosystem, which are called containerd and runc. These two are responsible for creating the containers. Containerd is also called as container runtime or container runtime interface, and runc is called as low level container runtime. So particularly this runc is the actual component which runs a container using the namespaces in the Linux kernel and the specification. We'll talk about this specification. The containerd is responsible for communicating with runc and sending the signal in order to create the container. So runc is the actual component which creates the containers. It will create the namespaces required for that container, all those 5 namespaces that we talked about earlier, and this is specification. So specifications is the detail about container, how the container should be started in that Linux system. This specification is laid out by OCI. OCI stands for Open Container Initiative. So it's an open governance system which is developed by Docker, which oversees the standard in which the containers are created. This standard is maintained in order to bring the uniformity in the process of container creation and utilization. So in any distro, either it be Ubuntu, Arch Linux, or any other distributions, this specification remains same. That allows us to use the same container in any distribution. So these standards are maintained by this OCI organization, which is an open governance structure. So this specification includes, let's see, if I use the command runc space, if I run the command runc and spec, it will generate a demo configuration, or maybe we would say specification file. In this specification file, everything about the container are listed. For example, by which user it should be started, the process inside the container, which user will own that process, what are the environment variable that need to be passed, also what will be the host name, mount points, what will be the volumes that will be mounted in the container, also the namespaces that will be created for that particular container. These all are the specification and standards laid out by OCI in order to create the standardization of utilization and use of containers. So those were the specification that runc uses in order to create the container. And the images download and store and creation, all that is handled by container D. That is why it is sometimes called as container runtime and container runtime interface. Why container runtime interface is because it is the actual interface that Docker engine uses in order to run the containers inside the host, and runc is the actual low level runtime which actually creates the namespaces and uses the specification in order to create that particular container. So the flow is, you write the command on your CLI, the CLI client sends an API request to Docker engine then uses that request and interprets it and sends the signal to container D. The container D utilizes runc in order to create container, and runc based on that specification and namespaces created will start the actual container. We make videos in system design, DevOps, coding projects, web development, blockchain, and explaining tools and technologies. If this is something that you are looking for, then hey, there is a subscribe button. See down there, and see you in the next one.